We are going to solve TS Maths Class 10 Chapter 1 Real Numbers SSC Board Exam Paper Solutions from 2015 to 2020. We solve problem 1. Expand log A cube B square C cube May 2022 for 1 mark. So solution is that first we write given log A cube B square C power 5. So we already know that log A into B into C is written as log A plus log B plus log C. By using this, we can write log A cube B square C power 5 is equal to log A cube plus log B square plus log C power 5. And log A cube log B square log C power 5 is in the form of log A power n is equal n into log A. By using this one, we can write log A cube as 3 log A, log B square as 2 log B, log C power 5 as 5 log C. Therefore, log A cube B square C power 5 is equal to 3 log A plus 2 log B plus 5 log C. We are going to solve second problem. Prove that root 5 plus root 7 is an irrational number. This is for 8 marks, May 2022. We can prove this one by contradiction method. For that one, let root 5 plus root 7 is equal to a by b as rational number, where a comma b are co-primes. Co-primes means which not have any common factor other than 1. Next we transpose root 5 from LHS to RHS. Then we can write root 7 is equal to a by b minus root 5. Next we squaring on both sides. Then we can write it as root 7 whole square is equal to a by b minus root 5 whole square. Now here we can cancel root and square, then we get 7 in LHS. RHS is in the form of x minus y whole square is equal to x square plus y square minus 2xy. By using, we expand it as a square by b square plus root 5 whole square minus 2a by b into root 5. Here root and 2 cancel, we can write it as a 5. Therefore, 7 is equal to a square by b square plus 5 minus 2a by b into root 5. Transpose 7 from LHS to RHS and minus 2a by b root 5 from RHS to LHS. Then we can write it as 2a by b root 5 is equal to a square by b plus 5 minus 7. 5 minus 7 is minus 2. Then we can write b square in denominator as LCM and numerator become a square minus 2 into b square. Therefore, 2a by b root 5 is equal to a square minus 2b square by b square. Next, we transpose 2a by b from LHS to RS, then we get b by 2a. Here b and here b we can cancel, then we get root 5 is equal to a square minus 2b square by 2ab. LHS root 5 is an irrational number, and in RHS a square minus 2b square by 2ab is a rational number. Therefore, root 5 is not equal to a square minus 2b square by 2ab. So, this contradicts our assumption root 5 plus root 7 is equal to a by b as rational number. Therefore, we can say that root 5 plus root 7 is an irrational number, hence proved. We are going to solve the problem. Insert 4 rational numbers between 3 by 4 and 1. Without using a plus b by 2 formula. For 1 mark, March 2015. First we write given numbers 3 by 4 and 1. To find the rational numbers between these two, we multiply numerator denominator by the 10. So we can write it as 3 by 4 into 10 by 10, which is equal to 30 by 40. And 1 is written as 1 by 1. Now we multiply numerator and denominator with 40, then we can write 1 into 40 by 1 by 40, which is equal to 40 by 40. Now we can write numbers between 30 by 40 and 40 by 40 as 31 by 40, 32 by 40, 33 by 40, 34 by 40 and so on up to 39 by 40, 40 by 40. Now we take any 4 rational numbers between 30 by 40 and 40 by 40. Then we can write 31 by 40, 32 by 40, 33 by 40, 34 by 40 or any four rational numbers between 30 by 40 and 40 by 40. Solve fourth problem. If the prime factoration of natural number n is 2 square into 3 square into 5 square into 7, how many consecutive zeros will it have at the end of it? Justify your answer. This is for 1 mark, June 2015. So it is given that natural number n is equal to 2 square into 3 square into 5 square into 7. 2 square means 4, 3 square means 9, 5 square means 25. 4 nines are 36, 25 into 7 we get 175. 36 into 175 we get 6300. So n is equal to 10 as 6300. So given number 6300 have two consecutive zeros at the end of it. We are going to solve the fifth problem. It is given that find the value of log 125 base 5. So to find this one, find the factors of 125, then we get 125 is equal to 5 cube. Then log 125 base 5 is written as log 5 cube base 5. Here log 5 cube base 5 is in the form of log a power n base 10 is equal to n into log a base 10. Then we can write it as 3 log 5 base 5. We already know that log a base a is equal to 1. So we can write log 5 base 5 as 1. So we can write 3 into 1. 3 into 1 is 3. Therefore log 125 base 5 is equal to 3. Now we are going to solve sixth problem. Write any two irrational numbers lying between 3 and 4. This is for 1 mark, March 2016. First we write the given two numbers 3 and 4. 3 is written as square root of 3 square. 3 square means 9. So we can write 3 is equal to root 9. And 4 is written as square root of 4 square. 4 square means 16. Then we can write 4 is equal to root 16. So between root 9 and root 16, root 10, root 11, root 12, root 13, root 14, root 15. Therefore, which are the required irrational numbers between 3 and 4? That means non-terminating, non-repeating numbers. Solve seventh problem. Find the value of log 256 root 2. So to find this one, first we find the factors of 256. After finding factors of 256, we get a 256 is equal to power 8. And we can write root 2 is equal to 2 power 1 by 2. By replacing these values, we can write it as log 2 power 8 base 2 power 1 by 2. So this is in the form of log x power a base x power b is equal to a by b log x base x. So it can be written as 8 by 1 by 2 log 2 base 2. We already know that log 2 base 2 is equal to 1 since it is in the form of log a base a is equal to 1. So we can replace log 2 base 2 with 1 and we get 8 by 1 by 2 into 1. Now we can write it as 8 into 2 by 1, 8 to the 16. Therefore, log 256 base root 2 is equal to 16. Now we are going to solve eighth problem. Find the HCF and LCM of 90 and 144 by prime factoration method. So by prime factoration method, we write the first prime factors of 90 as 90 is equal to 2 into 3 into 3 into 5 and prime factors of 144 are written as 2 into 2 into 2 into 2 into 3 into 3. Factors of 90 and 144. 2 common factor and 3 are common factors. Therefore 2 comma 3, comma 3 are common factors of 90 and 144. Therefore, HCF of 90, comma 144 is written as 2 into 3 into 3, which is equal to 18. Next, LCM of 90 and 144 is written as HCF into remaining factors of 90 and 144. We already calculated HCF as 18 and the remaining prime factors are 5, 2, 2, 2. Then LCM of 90, 144 is written as 18 into 5 into 2 into 2 into 2. So 5 into 2 into 2 into 2 is written as 40. Therefore, LCM of 90, 144 is written as 18 into 40. 18 into 40 is equal to 720. Therefore, LCM of 90, 144 is equal to 720. Next, we are going to solve ninth problem. In this, it is given that is log 81 base 3 is rational or irrational. Justify your answer. Solution. To solve this one, first to write the given data, that is log 81 base 3. To solve this one, first we find the factors of 81. Then we get the factors of 81 as 3 into 3 into 3 into 3, that is 3 power 4. So we can write log 81 base 3 is equal log 3 power 4 base 3. So it is in the form of log a power n is equal n into log a. So it can be written as 4 log 3 base 3. We already know that log 3 base 3 is 1. Therefore we replace this one with 1. Then we get 4 into 1. Therefore log 81 base 3 is equal to 4. We already know 4 is a rational number. Therefore log 81 base 3 is a rational number. Now we are going to solve 10th problem. It is given that expand log 385 base 10. To expand this one, first of all, we have to find the factors of 385. So 385 is written as 5 into 7 into 11. So we replace 385 with 5 into 7 into 11. Then log 385 base 10 is equal to written as log 5 into 7 into 11 base 10. So it is in the form of log ABC is equal log A plus log B plus log C. Then it is written as log 5 base 10 plus log 7 base 10 plus log 11 base 10. 11th problem, find the HCF of 24 and 33 by using division algorithm. This is for 1 mark March 2019. By Euclid's division algorithm, we can write 0 less than or equal to r less than b. Now, we divide 33 with 24. Then we get 1 quotient and 9 remainder. Then this step is written as 33 is equal to 24 into 1 plus 9. Here remainder 9 is not equal to 0. Then we divide 24 with 9. Then we get 2 as a quotient and 6 as a remainder. Then it is written as 24 is equal to 9 into 2 plus 6. Here 6 is not equal to 0. Then we divide 9 with 6. Then we get a quotient 1 and remainder 3. Then this is written as 9 is equal to 6 into 1 plus 3. Next, here 3 is remainder which is not equal to 0. Then we have to divide 6 with 3. Then we get 2 as a quotient and the remainder is 0. Then we can write this step as 6 is equal to 3 into 2 plus 0. Therefore, we can say so 3 is the HCF of 33 and 24. We are going to solve 12th problem. Find the value of log 128 base root 2. It is given for 1 mark June 2018. To find its value, we have to first factorize 128. After factorizing 128, we get 2 power 7. Then we replace 128 with 2 power 7. Root 2 is written as 2 power 1 by 2. Then log 128 base root 2 is written as log 2 power 7 base 2 power 1 by 2.
It is in the form of log a power n base a power m is equal to n by m log a base a. Then it is written as 7 by 1 by 2 log 2 base 2. 7 1 by 2 is written as 7 into 2 by 1 and log 2 base 2 is written as 1. Next 7 2s are 40, then we get to 14. Therefore log 128 base root 2 is equal to 14. Now we are going to solve 13th problem. Ramu says if log x base 10 is equal to 0, then value of x is equal to 0. Do you agree with him? Give reason. To solve this one, first of all, write the given data, that is log x base 10 is equal to 0. By removing log, we can write it as x is equal to 10 to the power of 0. We already know 10 to the power of 0 is equal to 1. Since we already know a power 0 is equal to 1. Here we get x is equal to 1. We already know x is not equal to 0. Therefore, we can write x is not equal to 0. So, I don't agree with Ramu's answer. We are going to solve 14th problem. Write any three numbers of two digits. Find the LCM and HCF of the above numbers by the prime factorization method. This is for 2 marks, March 2015. According to the given problem, we have to consider any three numbers of two digits. Let I consider 10, 12, 14. These are the any two-digit numbers. Next, we have to find the prime factors of 10, 12, 14. Then we can write prime factors of 10 as 2 into 5 and the prime factors of 12 as 2 into 2 into 3 and the 14 prime factors as 2 into 7. In these three, 2 is common. So, 2 is a common factor of 10, 12, 14. Therefore, we can write 2 is HCF of 10, 12, 14. We already know that LCM is equal to HCF into remaining prime factors of 10, 12, 14. Then we can write it as HCF value is 2. Then remaining prime factors are 5, 2, 3, 7. Then we get 420. That is the LCM of 10, 12, 14. Now we are going to solve 15th problem. Give an example for each of the following. First one, the product of two irrational numbers is a rational number. And second one is the product of two irrational numbers is an irrational number. This is for 2 marks, March 2015. So let root 2 and root 50 are any two rational numbers. Then we multiply, that is root 2 into root 50 is equal to 10 as 2 into 50, which is equal to 10 as root 100. We already know root 100 is equal to 10. 10 is a rational number. Therefore, product of any two irrational numbers is equal to rational number. Second one, let root 2 and root 3 are any two irrational numbers. Then their product, that is root 2 into root 3 is equal to root 2 into 3, which is equal to root 6. Here root 6 is an irrational number. Therefore, the product of any two irrational numbers is equal to irrational number. Now we are going to solve 16th problem. State with reasons which of the following are rational numbers and which are irrational numbers. This is for 2 marks, June 2015. So first one is root 225 into root 4. So first we have to find the factors of 225 and 4. So 225 factors are written as 5 into 5 into 3 into 3. Then we get a root 225 is equal to 15 and the root 4 is written as 2. Then root 225 into root 4 is equal to 15 into 2, 15 to the 30. 30 is a rational number. Therefore, we can say product of two irrational numbers need not be a irrational number. Second one, 6 root 50 plus 8 root 125. 50 is written as 25 into 2 and 125 is written as 25 into 5. Then we already know that root 25 is equal to 5. Then we can write 6 into 5 root 2 plus 8 into 5 into root 5. So 6 5 is 30. Then we can write it as 30 root 2 plus 8 5 is 40. Then we get 40 root 5. Therefore 30 root 2 plus 40 root 5 is an irrational number. Sum of irrational numbers may be irrational numbers. Solve 17th problem. Expand log 1125 by 32. To expand this one, first of all, we have to find the factors of 1125 and 32. So 1125 factors written as 5, 5, 5, 3 and 3. Then 1125 is written as 5 cube into 3 square. And the 32 factors are written as 2 power 5. Then we can write log 1125 by 32 is equal to log 5 cube into 3 square by 2 power 5. This is in the form of log a by b is equal to log a minus log b. Then we can write it as log 5 cube into 3 square minus log 2 power 5. Here log 5 cube into 3 square is in the form of log a into b, which is equal to log a plus log b. Then we can write it as log 5 cube plus log 3 square. Here log 5 cube, log 3 square, log 2 power 5 is in the form of log a power n. Then we can write it as n into log a. Therefore, we can write log 5 cube as 3 log 5, log 3 square as 2 log 3, and log 2 power 5 as 5 log 2. Therefore, log 1125 by 32 is equal to 3 log 5 plus 2 log 3 minus 5 log 2. All 18th problem. This is for 2 marks June 2015. Express the numbers 6825 and 3825 as a product of its prime factors. Second one, find the HCF and LCM of the above numbers by using their products of prime factors. Third one is justify your answer. So first to write the given numbers that are 6825 and 3825. So first of all, we find the prime factors of 6825 as 5 into 5 into 3 into 91, and the prime factors of 3825 as 5 into 5 into 3 into 51. Here 91 also prime factor, 51 also prime factor. In both prime factors 5, 5, 3 are common. Then we can say HCF of 6825 and 3825 as 5 into 5 into 3, which is equal to 75. And LCM of these two is written as HCF into remaining prime factors of the two numbers. So we can write LCM is equal to 5 into 5 into 3 into 91 into 51. Then we get 3,48,075. Next product of numbers is equal to 6,825 into 3,825. By multiplying these two numbers, we get 26105625. Then we already know that LCM into HCF is equal to 348075 into 75. Then we get this product as 26105625. Here, by observing above, the product of two numbers is also equal to product of LCM and HCF. Therefore, we can conclude that product of any two numbers is equal to LCM and HCF of that numbers. Going to solve 19th question, that is, if x square plus y square is equal to 7xy, then show that 2 log x plus y is equal to log x plus log y plus 2 log 3. This is for 2 marks March 2016. So first of all, write the given x square plus y square is equal to 7xy. On LHS, To complete the square, we add 2xy on both sides. Then we can write x square plus y square plus 2xy is equal to 7xy plus 2xy. In LHS, it is in the form of a plus b whole square. Then we can write x plus y whole square. On RHS 7xy plus 2xy, we can write 9xy. Now take logarithm on both sides, then we can write log x plus y whole square is equal to log 9xy. So here log x plus y whole square is in the form of log a power n is equal to n log a. Then we can write it as 2 log x plus y. In RHS, log 9xy is in the form of log a into b into c. Then it is equal to log a plus log b plus log c. Therefore, we can write log 9xy as log 9 plus log x plus log y. Hence proved. We are going to solve 20th problem. Express 2016 as a product of prime factor. This is for 2 marks June 2016. So we divide 2016, then we can write it as 2 times of 1008, and 1008 is written as 2 times 504, and 504 is written as 2 times of 252, and 252 is written as 2 times of 126, and 126 is written as 2 times of 63, and 63 is written as 3 times of 21, and 21 is written as 3 times of 7. Here 2 is repeated 5 times, and 3 is repeated 2 times, and 7 is repeated 1 time. Therefore 2016 is written as 2 power 5 into 3 square into 7 power 1. We are going to solve 21st problem. Write any two 3-digit numbers, find their LCM by GCD by prime factorization method. This is for 2 marks March 2017. So according to given problem, we have to take two numbers which have 3 digits. Let 100 and 105 are any two 3-digit numbers. First we find GCD. To find GCD, we divide 100 and 105 with 5. So 520 is 100, 521 is 105. So 5 is only common factor of 100 and 105. Therefore 5 is GCD of 100 and 105. Next we find the LCM by dividing 100 and 105. First we divide 5 20s and 5 21s. Next we divide 20 with 2 10s. Next we divide 10 with 2 5s are 10. Next we divide 5 with 5 ones are 5. Next we divide 21 3 7s are 21. Next we divide 7 with 7 ones are 7. So we get all prime factors. So LCM of 100 and 105 is equal to written as HCF into remaining prime factors of 100 and 105. So here 5 is HCF, remaining prime factors are 2, 2, 5, 3, 7. So we can write 5 into 2 into 2 into 5 into 3 into 7. By multiplying these, we get 2100. Therefore, LCM of 100 and 105 is equal to 2100. Solve 22nd question. Prove that 2 plus root 3 is irrational. This is for 2 marks June 2017. To prove 2 plus root 3 is an irrational number by contradiction method. Let 2 plus root 3 as a rational number. Then we can write 2 plus root 3 is equal to p by q, where p comma q are co-primes and q not equal to 0. Next we transpose 2 from LHS to RHS. Then we can write root 3 is equal to p by q minus 2. By taking LCM, we get denominator as q and a numerator become p minus 2q. So in LHS, root 3 is a rational number. In RHS, p minus 2q by q is a rational number. These two are not equal. Then we can write root 3 is not equal to p minus 2q by q. So our assumption 2 plus root 3 is rational number is wrong. So we can say that 2 plus root 3 is an irrational number. Now we are going to solve 23rd problem. Show that log 162 by 343 plus 2 log 7 by 9 minus log 1 by 7 is equal to log 2. To prove this one, first of all consider LHS, that is log 162 by 343 plus 2 log 7 by 9 minus log 1 by 7. Here log 162 by 343 and log 7 by 9 log 1 by 7 is in the form of log A by B is equal to log A minus log B. Then we can write it as log 162 minus log 343 plus 2 times of log 7 minus log 9 minus of log 1 minus log 7. Here next we find the factors of 162 and 343. Then we can write 162 as 2 into 3 power 4 and 343 is written as 7 cube. Then we can write it as log 2 into 3 power 4 minus log 7 cube plus 2 times of log 7 minus log 3 square. Here 9 is written as 3 square. And after removing the bracket we can write minus log 1 plus log 7. Next, log 2 into 3 power 4 is in the form of log AB is equal to log A plus log B. Then we can write log 2 plus log 3 power 4. Here log 3 power 4 is in the form of log A power n is equal to n into log A. Then we can write it as 4 log 3. And log 7 cube is also in the form of log A power n is equal to n into log A. Then we can write it as minus 3 log 7. After removing the bracket here, 2 times of log 7 minus 2 log 3 is written as 2 log 7 minus 4 log 3. Here plus 4 log 3 and minus 4 log 3 is cancelled. Next, we already know that log 1 is equal to 0. Then we write the log 1 value as 0. Next, we can write the remaining terms as log 2 minus 3 log 7 plus 2 log 7 plus log 7. By adding 2 log 7 plus log 7 we get 3 log 7. Now we can cancel minus 3 log 7 and plus 3 log 7. Then we get log 2. Therefore, log 162 by 343 plus 2 log 7 by 9 minus log 1 by 7 is equal to log 2. Hence proved. We are going to solve 24th problem, that is for 2 marks, June 2018. Lalita says that HCF and LCM of two numbers 80 and 60 are 20 and 120 respectively. Do you agree with her? Justify. So given two numbers are 80 and 60 and their HCF is given as 20 and LCM is given as 120. We already know that HCF into LCM is equal to product of two numbers. Here HCF is 20 and LCM is 120 and the first number is 80 and second number is 60. By multiplying 20 into 120 we get 2400, and by multiplying the two numbers, that is 80 into 60, we get to 4800. 2400 is not equal to 4800. This is false. So I do not agree with Lalita. 25th problem. Use Euclid's division lemma to show that the cube of any positive integer is in the form of 7m or 7m plus 1 or 7m plus 6. March 2016 for 4 marks. By Euclid's division lemma we can write a is equal to b cube plus r and condition is 0 less than or equal to r less than b. Let this one as a equation 1. From this one we can write b value as 7. Then we get r is equal 0 to 6. Then we first substitute b is equal 7 and r is equal 0 in equation 1. Then we can write a is equal to 7 cube plus 0 which is equal to 7 cube. Let this one as a equation 2. Next we substitute b is equal to 7 and r is equal to 1 in equation 1. Then we get a is equal to 7 cube plus 1. Let this one as a equation 3. Next we substitute b is equal to 7 and r is equal to 1 in equation 1. Then we can write a is equal to 7 cube plus 2. Let this one as a equation 4. And next substitute b is equal to 7 and r is equal to 3 in equation 1. Then we can write a is equal to 7 cube plus 3. Let this one as a equation 5. Next we substitute b is equal to 7 and r is equal to 4 in equation 1. Then we get a is equal to 7 cube plus 4. Let this one as a equation 6. Next we substitute b is equal to 7 and r is equal to 5 in equation 1. Then we get a is equal to 7 cube plus 5. Let this one as a equation 7. Next we substitute b is equal to 7 and r is equal to 6 in equation 1. Then we can write A is equal to 7q plus 6. Let this one as a equation H. Next we have to find the cube of equation 2. Then we can write it as a cube is equal to 7q whole cube is equal to 7 times of 7 square q cube, which is equal to written as 7m. Here let m is equal to 7 square q cube. Next we find the cube of equation 3. Then we can write a cube is equal to 7q plus 1 whole cube. 7q plus 1 whole cube is in the form of x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. Then we expand the RHS as 7q whole cube plus 3 times of 7q whole square into 1 plus 3 times of 7q times of 1 square plus 1 cube. Here 1 cube means 1 and 1 square means 1. And 7q whole square cube is written as 7 cube q cube plus 7 q whole square written as 7 square q square. In these three terms we can take out a 7 common, then we can write 7 times of 7 square q cube plus 3 times of 7 into q square plus 3 cube. So let 7 square q cube plus 3 times of 7q square plus 3q as equal to m. Then we can write a q is equal to 7m plus 1. Equation 4 is written as a cube is equal to 7q plus 2 whole cube. In RHS 7q plus 2 whole cube is in the form of x plus y whole cube, which is equal to 7x cube plus 3x square y plus 3xy square plus y cube. By expanding RHS we can write it as 7q whole cube plus 3 times of 7q whole square into 2 plus 3 times of 7q into 2 square plus 2 cube. Here 2 cube means 8 and 2 square means 4. And 8 is written as 7 plus 1. In these 4 terms we can take out 7 common. Then we can write it as 7 times of 7 square q cube plus 3 times of 7 into q square times 2 plus 3 cube times 4 plus 1. Let 7 square q cube plus 3 times of 7 q square times 2 plus 3 cube times 4 plus 1 as equal to m. Then we get a cube is equal to 7m plus 1. To find the cube of equation 5, that is a cube is equal to 7q plus 3 whole cube. RHS is in the form of x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By expanding RHS using this formula, we can write it as 7q whole cube plus 3 times of 7q whole square times 3 plus 3 times of 7q times 3 square plus 3 cube. 3 cube is written as 27 and 3 square is written as 9. And 27 is written as 21 plus 6. And in these 4 terms we can write 7 as common, then we can write it as 7 times of 7 square q cube plus 3 times of 7 q square times 3 plus 3 q times 9 plus 3. Let 7 square q cube plus 3 times of 7q square times 3 plus 3q 9 plus 3 is equal to m. Therefore we can write a cube is equal to 7m plus 6. In the cube of equation 6, that is a cube is equal to 7 cube plus 4 whole cube. It is in the form of x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this we can expand RHS as 7q whole cube plus 3 times of 7q whole square times 4 plus 3 times of 7q times 4 square plus 4 cube. Here 4 cube is written as 64 and 64 again split into 63 plus 1. And 63 can be written as 7 into 9. From that one we taken out 7 common. So in first term, second term, third term and fourth term we have 7 common. So after taking 7 common we can write it as 7 times of 7 square q cube plus 3 times of 7 q square times 4 plus 3 cube times 4 square plus 9. Let this one as m. Then we can write above equation as 7 times of m plus 1. Find the cube of equation 7, that is a cube is equal to 7 cube plus 5 whole cube. This is in the form of x plus 5 whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this one, we expand the RHS as 7q whole cube plus 3 times of 7q whole square times 5 plus 3 times of 7q times 5 square plus 5 cube. Here 5 cube means 125. 125 is written as 7 times of 17 plus 6, that is 119 plus 6. From these 4 terms we take out 7 common, then we can write it as 7 times of 7 square q plus 3 times of 7q square times 5 plus 3q times 5 square. Here we take out 7, then remaining is 17. So whatever is in the bracket, let that one as a m. Then we replace with m. Then we can write a cube is equal to 7m plus 6. Now we have to find the cube of equation 8, that is a cube is equal to 7q plus 6 whole cube. It is in the form of x plus 5 whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this formula, we expand RHS as 7q whole cube plus 3 times of 7q square times 6 plus 3 times of 7q times 6 square plus 6 cube. Here 6 cube we get 216. 216 is split into 7 times of 30 plus 6. From these 4 terms we take out 7 common. Then we can write it as 7 times of 7 square q cube plus 3 times of 7q square times 5 plus 3 q times 5 square plus 30 and remaining 6. Now let whatever is in this bracket is equal to m. Then we can write a cube is equal to 7m plus 6. So from above we can say cube of any positive integer is in the form of 7m or 7m plus 1 or 7m plus 6. We are going to solve 26th problem. It is given that prove that root 2 minus 3 root 5 is an irrational number. This is for 4 marks, March 2016. We can prove this one by contradiction method. So let root 2 minus 3 root 5 is a rational number. Then we can write root 2 minus 3 root 5 is equal to p by q, where p, q are co-primes. They not have any common factor other than 1 and q should not equal to 0. So next we transpose minus 3 root 5 from LHS to RHS. Then we can write root 2 is equal to p by q plus 3 root 5. Next we have to squaring on both sides. Squaring we can write it as root 2 whole square is equal to p by q plus 3 root 5 whole square. It is in the form of x plus 5 whole square is equal to x square plus 5 square plus 2xy. And in LHS, root and square cancel, we get 2. RHS, by using formula we expand it as p by q whole square plus 3 root 5 whole square plus 2 times of p by q times 3 root 5. And p by q whole square is written as p square by q square, and 3 root 5 whole square is written as 3 square times of root 5 whole square, and 2 3s are 6 p by q. Next 3 square is written as 9, and here root and square cancel, we can write 5. Therefore 9 5s are 45. Finally we can write our equation as 2 is equal to p square by q square plus 45 plus 6 p by q root 5. Next we have to transpose p square by q square and 45 from RHS to LHS. Then we can write it as 2 minus 45 minus p square by q square is equal to the remaining term 6 P by Q root 5. Simplifying to minus 45 we get a minus 43. Next we take out the LCM as Q square. Then we can write numerator as minus 43 Q square minus Q square. Denominator as Q square. And next we transpose 6P from numerator to denominator of LHS and Q from denominator of RHS to numerator of LHS. Then we can write it as 43 Q square minus P square by Q square times Q by 6P, which is equal to root 5. Here we can cancel 1 Q here and 1 Q here. Then we can write it as minus 43 Q square minus P square by 6PQ is equal to root 5. Finally, we get minus 43Q square minus P square by 6PQ is equal to root 5. In LHS, minus 43Q square minus P square by 6PQ is a rational number, that is minus 43Q square minus P square 6PQ are co-prime, so it is a rational number, and in RHS root 5 is a irrational number. So we can say LHS is not equal to RHS. Then we can write minus 43 Q square minus P square by 6PQ is not equal to root 5. This contradicts our assumption root 2 minus 3 root 5 is an irrational number, hence proved. We are going to solve 27th problem, Euclid's division lemma, to show that cube of any positive integer is of the form 3p or 3p plus 1 or 3p plus 2 for any integer p. So this is for 4 marks, June 2016. By Euclid division lemma, we can write a is equal to b cube plus r, let this one as a equation 1, and where the condition is 0 less than or equal to r less than b. According to the given problem, we can take b is equal to 3, then r is equal to 0, 1, 2. Now we substitute b is equal to 3 and r is equal to 0 in equation 1, then it implies a is equal to 3q plus 0. Then we get a is equal to 3q. Next we substitute b is equal to 3 and r is equal to 1 in equation 1, then we can write a is equal to 3q plus 1. Let this one as a equation 3. Next we substitute b is equal to 3 and r is equal to, then equation 1 implies a is equal to 3q plus 2. Let this one as a equation 4. Case 1. When a is equal to 3q, then a cube is written as a cube is equal to 3q whole cube. Here 3q whole cube is written as 3q times q cube. Here we take out 3 common, then we can write it as 3 times of 3 square q cube. Let it 3 square q cube is equal to p. Then we get a cube is equal to 3p. Next case 2, when a is equal to 3q plus 1, then cube of a cube is written as a cube is equal to 3q plus 1 whole cube. This is in the form of x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. Then RHS becomes 3q whole cube plus 3 times of 3q whole square times 1 plus 3 times of 3 cube times 1 square plus 1 cube. Here 1 cube means 1, here 1 square means 1. Then we can write our equation as 3 cube q cube plus 3 times of 3 square q square plus 3 times of 3 cube plus 1. In first 3 terms we take out 3 common, then we can write it as 3 times of 3 square q cube plus 3 square q square plus 3 cube plus 1. Here what is in the bracket, let it as a p. Then we can write this equation as 3p plus 1. Therefore a cube is equal to 3p plus 1. A is equal to 3 cube plus 2, then cube of a is equal to 3 cube plus 2, written as a cube is equal to 3 cube plus 2 whole cube 3 cube plus 2 whole cube is in the form of x plus y whole cube, which is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this formula, we can write RHS as 3q whole cube plus 3 times of 3q whole square times 2 plus 3 times of 3q times 2 square plus 2 cube. Here 3q whole cube is written as 3 cube q cube, and 3q whole square is written as 3 square q square, and 2 cube is written as 8. To take 3 common, we write 8 as 6 plus 2. Then from these 4 terms we can take out 3 common. Then we can write 3 times of 3 square q cube plus 3 square q square 2 plus 3q times 2 square plus 2, and plus 2 remaining here. So let what is in the bracket, let that one as a p. Then we can write 3p plus 2. Therefore, we get a cube is equal to 3p plus 2. So from above we can say cube of a positive integer is of the form 3p or 3p plus 1 or 3p plus 2 for any integer p. Now we are going to solve 28th problem. Prove that root 3 minus root 5 is an irrational number. This is for 4 marks, June 2016. To prove root 3 minus root 5 is an irrational number by contradiction method, let root 3 minus root 5 is a rational number. Then we can write root 3 minus root 5 is equal to p by q, where p comma q are co-primes and q not equal to 0. Next we transpose root 5 from LHS to RHS. Then we can write it as root 3 is equal to p by q plus root 5. Next we have to squaring on both sides. Then we can write it as root 3 whole square is equal to p by q plus root 5 whole square. Now we cancel root and square, then we get 3 on LHS, and p by q plus root 5 whole square is in the form of a plus b whole square is equal to a square plus b square plus 2ab. By using this formula, we expand it as p by q whole square plus root 5 whole square plus 2 times of p by q times root 5. Here p square by q square is written as p square by q square plus root and 2 cancel, we get 5, and we can write this term as 2p by q root 5. Next we transpose 5 and p square by q square from RHS to LHS. Then we can write it as 3 minus 5 minus p square by q square is equal to 2p by q root 5. 3 minus 5 is minus 2. Then we can write next step as minus 2 minus p square by q square is equal to p by q root 5. Next denominator we have q square, then we get LCM as q square. Then we can write numerator as minus 2 q square minus p square, which is equal to 2p by q root 5. 2p by q from RHS to LHS, it will become reciprocal. Then we can write it as q by 2p in LHS. Here q and q cancel, then we can write numerator as minus 2q square minus p square by 2pq is equal to root 5. In LHS, minus 2q square minus p square and denominator 2pq are co-primes. They not have any common factor. So we can say that it is a rational number. In RHS, root 5 is a rational number. So we can say that LHS is not equal to RHS. So this contradicts our assumption root 3 minus root 5 is rational number. Therefore we can say that root 3 minus root 5 is an irrational number, hence proved. To solve 29th problem, use Euclid's division lemma to show that the square of any positive integer is of the form 5n or 5n plus 1 or 5n plus 4. for 4 marks, March 2017. By Euclid's division lemma, we can write A is equal to BQ plus R. Let this one as a equation 1. The condition is 0 less than or equal to R less than B. From the given problem, we can take P is equal to 5. Then we can write R values are from 0 starting to up to 4. So when B is equal to 5 and R is equal to 0, then equation 1 implies A is equal to 5Q plus 0. Then we can get A is equal to 5Q. Let this one as a equation 2. Next, substitute B is equal to 5 and R is equal to 1. Then equation 1 becomes A is equal to 5Q plus 1. Let this one as a equation 3. Next, substitute B is equal to 5 and R is equal to in equation 1, then it becomes A is equal to 5Q plus 2. Let this one as a equation 4. Next, substitute B is equal to 5 and R is equal to 3 in equation 1, then A is equal to 5Q plus 3. Let this one as a equation 5. Next, substitute B is equal to 5 and R is equal to 4 in equation 1. It implies A is equal to 5Q plus 4. Let this one as a equation 6. When A is equal to 5Q is a positive integer, then square of it is written as A square is equal to 5Q whole square. Here 5Q whole square is written as 5 square Q square. And we can write 5 square Q square as 5 times of 5Q square. Let 5Q square is equal to n. Then we can write it as A square is equal to 5n. Let this one as a another equation. So next case 2, when A is equal to 5Q plus 1 is a positive integer, then its square is written as A square is equal to 5Q plus 1 whole square. It is in the form of x plus y whole square is equal to x square plus 2xy plus y square. Then we can expand RHS as 5Q whole square plus 2 times of 5Q times 1 plus 1 square. Here 5Q whole square is written as 5 square Q square and 1 square is written as 1. Now first two terms we take out 5 common, then we can write it as 5 times of 5Q square plus 2Q and plus 1. Now we substitute 5Q square plus 2Q is equal to n, then we can write A square is equal to 5n plus 1. So this one as a equation 2. When A is equal to 5Q plus 2 is a positive integer, then its square is written as A square is equal to 5Q plus 2 whole square. RHS is in the form of x plus y whole square is equal to x square plus 2xy plus y square. Then we can write it as 5Q whole square plus 2 times of 5Q times 2 plus 2 square. Here 2 square value is 4 and 5Q whole square is written as 5 square Q square. In first two terms we take out 5 common, then we can write it as 5 times of 5Q square plus 2 times Q times 2 plus 4. Next, let 5Q square plus 2Q times 2 is equal to n, then we can write A square is equal to 5n plus 4. Let this one as a equation 3. Next case 4, when A is equal to 5Q plus 3 is a positive integer, then its square is written as A square is equal to 5Q plus 3 whole square. RHS is in the form of x plus 5 whole square is equal to x square plus 2xy plus y square. Then we can expand it as 5Q whole square plus 2 times of 5Q times 3 plus 3 square. Here 3 square means 9 and 5Q whole square is written as 5 square Q square. From this, and we write 9 as 5 plus 3. From these 3 terms we take out 5 common, then we can write it as 5 times of 5Q square plus 2Q times 3 plus 1. Now let 5Q square plus 2Q times 3 plus 1 is equal to n. Then we can write it as A square is equal to 5n plus 3. Let this equation as a 4. When A is equal to 5Q plus 4 is a positive integer, then its square is written as A square is equal to 5Q plus 4 whole square. RHS is in the form of x plus y whole square is equal to x square plus 2xy plus 2xy plus y square. By using this formula, we can expand it as 5Q whole square plus 2 times of 5Q times 4 plus 4 square. Here 4 square means 16 and 5Q whole square is written as 5 square Q square. And here 16 is split into 2 terms as 15 plus 1. From these 3 terms we take out 5 common, then we can write it as 5 times of 5q square plus 2q times 4 plus 3. Let 5q square plus 2q times 4 plus 3 is equal to n. Then we get a square is equal to 5n plus 1. Let this one as a equation 5. From equation 1, 2, 3, 4 and 5, we can say that square of any positive integer is in the form of 5n or 5n plus 1 or 5n plus 4, where n is any positive integer. We are going to solve 30th problem. Use division algorithm to show that the square of any positive integer is of the form 5m or 5m plus 1 or 5m plus 4. This is for 4 marks, June 2019. By Euclid's division lemma, we can write a is equal to bq plus r. Let this one as a equation 1, and condition is that 0 less than or equal to r less than b, where b can be written as 5 from the given problem. Then we get r is equal to 0, 1, 2, 3, 4, which is less than b. So positive integer a is written as when b is equal to 5 and r is equal to 0. Then equation 1 implies a is equal to 5q plus 0, that is 5q. And when b is equal to 5 and r is equal to 1, then equation 1 is written as a is equal to 5q plus 1. And when b is equal to 5 and r is equal to 2, then equation 1 implies a is equal to 5q plus 2. Similarly, when b is equal to 5 and r is equal to 3, then equation 1 implies a is equal to 5q plus 3. And when b is equal to 5 and r is equal to 4, then equation 1 implies a is equal to 5q plus 4. According to the given problem, square of a positive integer a is written as when a is equal to 5q, then square of this is written as a square is equal to 5q whole square. 5q whole square is written as 5 square q square, and this 5 square q square is written as 5 times of 5q square. Let 5q square is equal to m, then we get a square is equal to 5m. Let this one as a equation 1. And when a is equal to 5q plus 1, square of a is written as a square is equal to 5q plus 1 whole square. In RHS, 5q plus 1 whole square is in the form of x plus 5 whole square is equal to x square plus 2x square plus y square. By using this formula, we can expand it as 5q whole square plus 2 times of 5q times 1 plus 1 square. Here 1 square means 1. And 5q whole square is written as 5 square q square. In these two terms, we take out 5 common. Then we can write it as 5 times of 5q square plus 2q plus 1. Let 5q square plus 2q is equal to m. Then we get a square is equal to 5m plus 1. Let this one as a equation 2. Is equal to 5q plus 2. Then square of a positive integer a is written as a square is equal to 5q plus 2 whole square. It is in the form of x plus y whole square is equal to x square plus 2xy plus y square. By using this one, we can write it as 5q whole square plus 2 times of 5q times 2 plus 2 square. 2 square is written as 4 and 5q whole square is written as 5 square q square. In the first two terms, we take out 5 comma and then we can write it as 5 times of 5q square plus 2q2 plus 4. Let 5q square plus 2 times of q times of 2 is equal to m. Then we can write it as a square is equal to 5m plus 4. Let this one as a equation 3. Next one, a is equal to 5q plus 3. Squaring of a positive integer a is written as a square is equal to 5q plus 3 whole square. It is in the form of x plus y whole square is equal to x square plus 2xy plus y square. By using this formula, we can write it as 5q square plus 2 times of 5q times of 3 plus 3 square. 3 square is written as 9 and 9 is split into 5 plus 4. In these three terms, we take out 5 common. Then we can write it as 5 times of 5q square plus 2 times of q times of 3 plus 1. Let 5q square 2 times of q times of 3 plus 1 is equal to m. Then we get a square is equal to 5m plus 4. Let this one as a equation 4. When a is equal to 5q plus 4, then square of a positive number a is written as a square is equal to 5q plus 4 whole square. It is in the form of x plus 5 whole square is equal to x square plus 2xy plus y square. By using this one, we can expand it as 5q whole square plus 2 times of 5q times of 4 plus 4 square. Here 4 square means 16. 16 is written as 15 plus 1. So in these three terms we take out 5 common, then we can write it as 5 times of 5q square plus 2q times of 4 plus 3 plus 1. Let 5q square plus 2q 4 plus 3 is equal to m. Then we can write a square is equal to 5m plus 1. Let this one as a equation 5. From equations 1, 2, 3, 4, 5, we can say square of any positive integer is in the form of 5m, m or 5m plus 1 or 5m plus 4. We are going to solve the first problem. If x square plus y square is equal to 27xy, then show that log x minus y by 5 is equal to 1 by 2 times of log x plus log y. This is for 4 marks, June 2017. To prove that one, first of all, we write the given data, that is x square plus y square is equal to 27xy. Next, we subtract 2xy on both sides because we required improve x minus y form. So x square plus y square minus 2xy is equal to 27xy minus 2xy. We subtracted minus 2xy on both sides. Here in LHS, it is in the form of x square plus y square minus 2xy as the x minus y whole square. So we replace x square plus y square minus 2xy with x minus y whole square. On RHS, by subtracting 27xy minus 2xy, we get to 25xy. So here again 25 is written as 5 square. Next we transpose 5 square from RHS to LHS. It will go to the denominator. Then we can write x minus 5 whole square by 5 square is equal to xy. Here we have square for both. We take out whole square. It can be written as x minus 5 by 5 whole square is equal to xy. Next we transpose square from LHS to the RHS. Then we can write it as x minus 5 by 5 is equal to xy whole power 1 by 2. On both sides, then we can write it as log x minus 5 by 5 is equal to log xy whole power 1 by 2. Here this is in the form of log a power n is equal to n log a. Then we can write it as 1 by 2 log xy. Here log xy is in the form of log xy is equal to log x plus log y. So log xy is written as log x plus log y. Therefore, log x minus 5 by 5 is equal to 1 by 2 times of log x plus log y. Hence proved. Now we are going to solve 32nd problem. Prove that root 3 plus root 5 is an irrational number. This is for 4 marks, March 2018. We can prove this root 3 plus root 5 as irrational number by contradiction method. Assume root 3 plus root 5 is a rational number. Then we can write root 3 plus root 5 as p by q, where p comma q are co-terms. It means p comma q not have other factors other than 1, and here q should not equal to 0. Next we transpose root 3 from LHS to RHS. Then we can write root 5 is equal to p by q minus root 3. Next we squaring on both sides. Then we can write root 5 whole square is equal to p by q minus root 3 whole square. On LHS root and square we can cancel, we get to 5. And RHS is in the form of x minus 5 whole square is equal to x square plus y square minus 2xy. Then we can write it as p by q whole square plus root 3 whole square minus 2 times of p by q times root 3. P by q whole square is written as p square by q square, and root and square cancel, you get to 3. Next we transpose 5 from LHS to RHS and minus 2p by q root 3 from RHS to LHS. Then we can write it as 2p by q root 3 is equal to p square by q square plus 3 minus 5. 3 minus 5 becomes minus 2. Here denominator have q square, then we take LCM as q square, then denominator become q square and denominator become p square minus 2q square. Next we transpose 2p by q from LHS to RHS, then it becomes a q by 2p on RHS. Here q and q cancel, we get a p square minus 2q square in numerator and the denominator become 2pq. Therefore, by observing, we can say that root 3 is a irrational on LHS and on RHS p square minus 2q square by and 2pq are co-terms. So, it is a rational number. Therefore, we can say LHS is not equal to RHS. Contradicts our assumption that root 3 plus root 5 is a rational number. Therefore, we can say that root 3 plus root 5 is an irrational number, hence proved.
Now we are going to solve 33rd problem. Show that cube of any positive integer will be in the form of 8m or 8m plus 1 or 8m plus 3 or 8m plus 5 or 8m plus 7, where m is a whole number. This is for 4 marks, March 2018. We can prove this one by Euclid's division lemma. We already know that by Euclid's division lemma we can write A is equal to BQ plus R and condition is 0 less than or equal to R less than B. Let this one as a equation 1. According to the given problem we can take out B is equal to 8, then we can write R is equal to 0 to 7. First we substitute B is equal to 8 and R is equal to 0 in equation 1. Then equation 1 is written as A is equal to 8q plus 0, then we get A is equal to 8q. According to the given problem, we have to find the cube of A is equal to 8q. Then we can write it as AQ is equal to 8q whole cube, and this can be written as 8 cube q cube, and this can be written as 8 times of 8 square q cube. Let 8 square q cube is equal to m, then we can write it as a cube is equal to 8m. Let this one as a Roman number 1 equation. Next we have to substitute b is equal to 8 and r is equal to 1 in equation 1. Then equation 1 is written as a is equal to 8q plus 1. Next we have to find the cube of a is equal to 8q plus 1. Then we can write it as a cube is equal to 8q plus 1 whole cube. It is in the form of x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this formula, we can expand RHS as 8q whole cube plus 3 times of 8q whole square times 1 plus 3 times of 8q 1 square plus 1 cube. So here 1 square is written as 1 and 1 cube is written as 1 and 8q whole square is written as 8 square q square and 8q whole cube is written as 8 cube q cube. From these three terms we take out 8 common, then it is written as 8 times of 8 square q cube plus 3 times of 8 q square plus 3q. Let 8 square q cube plus 3 times of 8 q square plus 3q is equal to m. Then we get a cube is equal to 8m plus 1. Let this one as a Roman number 2 equation. Next we substitute b is equal to 8 and r is equal to 2 in equation 1. Then a is equal to 8 cube plus 2. Then we next to find cube of a is equal to 8 cube plus 2. Then it is written as a cube is equal to 8 cube plus 2 whole cube. It is in the form of 8 x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. By using this identity we can write it as 8q whole cube plus 3 times of 8q square times 2 plus 3 times of 8q2 square plus 8. So 8q whole cube is written as 8 cube q cube and 8q whole square written as 8 square q square. From these 4 terms we take out 8 common, then we can write it as 8 times of 8 square q cube plus 3 times of 8 q square times 2 plus 3 times of q 2 square plus 1. Let this one as a m, then we get a cube is equal to 8m. Let this one as a equation 3 Roman number. Next we substitute b is equal to 8 and r is equal to 3 in equation 1. Then equation 1 becomes a is equal to 8 cube plus 3. Next we find the cube of this one. Then we can write a cube is equal to 8 cube plus 3 whole cube. By using the x plus y whole cube identity, we get after solving we get 8 times of 8 square cube plus 3 times of 8 q squared times 3 plus 3 times of q 3 square plus 3 plus 3. Here 3 cube means 27 and 27 is written as 24 plus 3. So the terms in the bracket let it as a m. Then we can write a cube is equal to 8m plus 3. Let this one as a Roman number 4 equation. So we substitute b is equal to 8 and r is equal to 4. Then equation 1 is written as a is equal to 8 cube plus 4. Then next we have to find the cube of a is equal to 8 cube plus 4. Then it is written as a cube is equal to 8 cube plus 4 whole cube. RHS is in the form of x plus y whole cube identity. Then we can write it as 8q whole cube plus 3 times of 8q whole square times 4 plus 3 times of 8q 4 square plus 4 cube. Here 4 cube is written as 64 and from these 4 terms we take out 8 common. Then we can write it as 8 times of 8 square q plus 3 times of 8q square times 4 plus 3q times 4 square plus 8. Let this one as a m. Then we can write it as a cube is equal to 8m. Let this one as a row number 5 equation. Next we find a by substituting b is equal to 8 and r is equal to 5. Then equation 1 becomes a is equal to 8 cube plus 5. Next we have to find the cube of a is equal to 8 cube plus 5. Then we can write it as a cube is equal to 8 cube plus 5 whole cube. It is in the form of x plus 5 whole cube identity. Then we can write it as 8q whole cube plus 3 times of 8q whole square 5 plus 3 times of 8q 5 square plus 5 cube. 5 cube is written as 125 and 128 is written as 120 plus 5. From these 4 terms we take out 8 common. Then we can write it as 8 times of 8 square q cube plus 3 times of 8q square times 5 plus 3q 5 square plus 15. Let this one as a m. Then we can write a cube is equal to 8m plus 5. Let this one as a equation 6 Roman number. Next we substitute b is equal to 8 and r is equal to 6 in equation 1. Then equation 1 implies a is equal to 8 cube plus 6. Next we have to find the cube of a is equal to 8 cube plus 6. Then we can write it as a cube is equal to 8 cube plus 6 whole cube. It is in the form of x plus y whole cube identity. Then we expand it as 8q whole cube plus 3 times of 8q whole square times 6 plus 3 times of 8q 6 square plus 6 cube. 6 cube is written as 216 and 216 is written as 27 into 8. From these 4 terms we take out 8 common. Then we can write it as 8 times of 8 square q cube plus 3 times of 8q square times 6 plus 3q 6 square plus 27. Let 8 square q cube plus 3 times 8q square times 6 plus 3q 6 square plus 27 is equal to m. Then we can write a cube is equal to 8m. Let this one as a row number 7 equation. Substitute a b is equal to 8 and r is equal to 7. Then equation 1 implies a is equal to 8 cube plus 7. Next we find the cube of a is equal to 8 cube plus 7. Then we can write it as a cube is equal to 8 cube plus 7 whole cube. It is in the form of x plus y whole cube identity. Then we can expand it as 8q whole cube plus 3 times of 8q square times 7 plus 3 times of 8q 7 square plus 7 cube. Here 7 cube is written as 343 and 343 is written as 336 plus 7. So we can split this one as to take 8 common. So from these 4 terms we take out 8 common. Then we can write it as 8 times of 8 square q cube plus 3 times of 8q square times 7 plus 3q 7 square plus 42. Let 8 square qq plus 3 times of 8q square 7 plus 3q 7 square plus 42 is equal to m. Then a cube is equal to written as 8m plus 7. Let this one as a Roman number 8 equation. From Roman number equations 1, 2, 3, 4, 5, 6, 7, 8, we can say cube of any positive integer is in the form of 8m or 8m plus 1 or 8m plus 3 or 8m plus 5 or 8m plus 7. Hence proved.
Going to 734th problem. Prove that root 2 plus root 11 is an irrational number. This is for 4 marks June 2018. We can prove root 2 plus root 11 is an irrational number by contradiction method. For this one, let root 2 plus root 11 is a rational number. Then we can write root 2 plus root 11 is equal to p by q, where p comma q are co-primes and q not equal to 0. Next we transpose root 2 from LHS to RHS, then we can write it as root 11 is equal to p by q minus root 2. Now we are squaring on both sides, then we can write root 11 square is equal to p by q minus root 2 whole square. Here on LHS, root and square cancel, we get 11. And RHS is in the form of x minus 5 whole square is equal to x square plus y square minus 2xy. Then we can expand it as p by q whole square plus root 2 whole square minus 2 p by q root 2. Here p by q whole square is written as p square by q square, and root and square cancel, we get 2. Next we transpose 11 from LHS to RHS and a minus 2p by q root 2 from RHS to LHS. Then we can write it as 2p by q root 2 is equal to p square by q square plus 2 minus 11. By subtracting we get a minus 9. Next, here q square is in the denominator, then we take q square as a LCM and the numerator is written as p square minus 9q square. Next, we require to transpose 2p by q from LHS to RHS. Then it becomes q by 2p on RHS. Then we can write it as root 2 is equal to p square minus 9q square by q square times q by 2p. Here we can cancel q and q. Then we get p square by 9 q square by 2 pq on RHS. Here root 2 is a irrational number on LHS and p square minus 9 q square by 2 pq are co-primes, so it is a rational number. So we can say that LHS is not equal to RHS. Then our assumption root 2 plus root 11 is equal to p by q is wrong. Then we can say that root 2 plus root 11 is an irrational number, hence proved. We are going to solve the 35th problem. Show that root 5 minus root 3 is an irrational number. It is for 4 marks June 2019. We can prove root 5 minus root 3 as an irrational number by contradiction method. For this one, let root 5 minus root 3 is equal to p by q, where p comma q are co-primes and q should not equal to 0. Next we transpose minus root 3 from LHS to RHS. Then we can write it as root 5 is equal to p by q plus root 3. Next we squaring on both sides, then we can write it as root 5 whole square is equal to p by q plus root 3 whole square. On LHS we can cancel root and square, then we get a 5. On RHS, p by q plus root 3 whole square is in the form of x plus y whole square is equal to x square plus y square plus 2xy. By using this formula, we expand RHS as p by q whole square plus root 3 whole square plus 2 times of p by q times root 3. We can write p by q whole square as p square by q square, and here root and square cancel, we get a 3. Next we transpose 3 from RHS to LHS and p square by q square from RHS to LHS. Then we can write it as 5 minus 3 minus p square by q square is equal to 2p by q root 3. Here 5 minus 3 is 2. Then we get to 2. 2 minus p square by q square on LHS and 2p by q root 3 on RHS. Here denominator is q square, then we get to q square LCM and numerator becomes 2q square minus p square. Next we have to transpose 2p by q from RHS to LHS, then it becomes q by 2p. Here we can cancel one q in numerator, another q in denominator. We get 2q square minus p square by 2pq is equal to root 3. On LHS 2q square minus p square and 2pq are 4 times. They not have any common factor other than 1. So we can say 2q square minus p square by 2pq is a rational number. On RHS we have root 3. It is a irrational number. Therefore we can write LHS is not equal to RHS. So our assumption root 5 minus root 3 is equal to p by q is a rational number is wrong. So we can say that root 5 minus root 3 is an irrational number, hence proved.
Now we are going to solve next problem. Find the mean of factors of 24. This is for 1 mark June 2023. So factors of 24 are written as 24 is equal to 24 times 1 and 24 is also written as 2 times of 12 and 24 is written as 3 times 8 and 24 is written as 4 times 6. Then the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. We already know that the main formula is written as x bar is equal to summation xi by n. Here summation xi means sum of the observations, n means number of observations. Here total number of observations are 8 and sum by adding 1, 2, 3, 4, 6, 8, 12 and 24 we get 60. So we divide 60 with 8, then we get 7.5. Therefore x bar is equal to 7.5. So mean of 24 factors is 7.5. To solve next problem, expand log 32 by 81 for 1 mark August 2022. To expand this one, first we find the factors of 32 and 81. Here 32 factors are written as 2 power 5 and 81 factors are written as 3 power 4. And here log 32 by 81 is in the form of log a by b is equal to log a minus log b. Then we can write it as log 32 minus log 81 and we replace 32 as 2 power 5 and 81 as 3 power 4. Then we can write it as log 2 power 5 minus log 3 power 4. Here log 2 power 5 is in the form of log a power n is equal to n log a and log 3 power 4 is also in the form of log a power n is equal to n log a. Then we can write log 2 power 5 as 5 log 2 and log 3 power 4 as 4 log 3. Therefore log 32 by 81 is equal to 5 log 2 minus 4 log 3. This is the expanded form. So we are going to solve next problem, that is if 2304 is equal to power x times 3 power y, then find the value of log x base y. This is for 2 marks June 2023. First we have the given 2304 is equal to power x times of 3 power y. Next we have to find the factors of 2304. After finding the factors we get 2 power 8 times 3 power 2. Then we can write it as 2 power 8 times of 3 power 2 is equal to power x times 3 power y. By comparing 2 power 8 and 2 power x, then we can write x is equal to 8, and by comparing 3 square and 3 power y, we get y is equal to 2. Then we can write log x base y is equal to log 8 base 2. Here 8 can be written as 2 cube. Then we get log 2 cube base 2. Here log 2 cube base 2 is in the form of log a power m base b is equal to m log a base b. So we can write 3 log 2 base 2. We already know log 2 base 2 is equal to 1. Then we can write it as 3 times of 1. Therefore, log x base y is equal to 3. Now we are going to solve next problem. Prove that 2 root 3 plus root 5 is an irrational number. This is for 4 marks, April 2023. So first given write 2 root 3 plus root 5. To prove that 2 root 3 plus root 5 is an irrational number by contradiction method. For this one, first of all, let 2 root 3 plus root 5 is equal to p by q, where p comma q are co-primes and q should not equal to 0. Next, we transpose root 5 from LHS to RHS. Then we can write it as 2 root 3 is equal to p by q minus root 5. Next, we have to squaring on both sides. Then we can write it as 2 root 3 whole square is equal to p by q minus root 5 whole square. Here, in LHS, we can write it as 2 square under root 3 whole square. Here, next, in RHS, p by q minus root 5 whole square is in the form of x minus y whole square is equal to x square plus y square minus 2xy. By using this formula, we can expand RHS as p by q whole square plus root 5 whole square minus 2 times of p by q times root 5. Here 2 square is written as 4 and root and 2 cancel. Then we get 3 in LHS, and p by q whole square is written as p square by q square, and root and square cancel, we get 5. Then we can write next step as 4 3s are 12 is equal to p square by q square plus 5 minus 2p by q root 5. Next we transpose 12 from LHS to RHS and minus 2p by q root 5 from RHS to LHS. Then we can write it as 2p by q root 5 is equal to p square by q square plus 5 minus 12. 5 minus 12 will become minus 7. Then we get 2p by q root 5 is equal to p square by q square minus 7. Here denominator have q square, then we get a LCM q square. Then numerator become p square minus 7q square. Next we transpose 2p by q from LHS to RHS. It will become q by 2p. Then we can write root 5 is equal to p square minus 7q square by q square times q by 2p. Here 1q in numerator and 1q in denominator cancel. Then we get p square minus 7q square in numerator and denominator we get 2pq. Here in LHS root 5 is an irrational number, and in RHS p square minus 7q square and 2pq are co-primes. Then we can say that p square minus 7q square by 2pq is a rational number. From these two statements we can write LHS is not equal to RHS. Let's say that root 5 is not equal to p square minus 7q square by 2pq. This contradicts our assumption 2 root 3 plus root 5 is a rational number. Therefore, we can say 2 root 3 plus root 5 is an irrational number. Hence proved.
Please like, share, subscribe our channel for latest updates by pressing the bell icon.
For more information, visit our website and blog www.mathswithnaseer.com and www.mathswithnaseerblogspot.com. Thank you.